Hello guys, in this video we are going to study STL or the standard template library. So in this video we are going to talk about vectors, stack, queues, unordered maps, sets, unordered sets, priority queue, iterators and some important functions. So with that, yeah, one thing I wanted to clarify is that if you're using these videos to study concepts, then what I'll recommend is that as you are watching the video, when I teach a concept, pause the video, try to code the same thing on your own. In that way you'll be able to learn more and the thing would become more ingrained in you. For example, the first topic I'm going to teach is vectors. So as soon as I'm done with vectors, what you should do is you should try to code the same thing up on your own and then test if it's working or not, or if you're having any other questions regarding the same. If you have any questions, then you can always ping me on Discord, or you can post your question on the Discord server. So yeah, with that, let's get started. So firstly, let's try to understand what vectors are, but before that, let's talk about arrays. So in the last video, I already asked you to study arrays. I hope all of you have already studied arrays, but if there's someone like who didn't get something, so in this video I'm still gonna give you a small overview of arrays so that you are able to understand it. So what are arrays? So arrays are basically collection of similar elements. So what do I mean by that? So let's say I ask you to store 5 numbers, right? So what you can do, you can actually create 5 integers. So we talked about integers in the previous lecture. So we can make 5 integers. So integer a, b, c, d, e. You'll call them int, 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 and then you can store some values in it. Would this method work? Yes, it definitely would work. But is this a clean code? No, it isn't. We could have used arrays and do we could have done this in a single line, but over here we are using different kind of variables for it. Also, one of the problem over here is, what if I tell you that I'm not initially telling you the number of variables you're going to use. So I can say that in a program, firstly ask user to tell the number of variables for number of variables, and then take the then take the inputs from them. So now this will become a problem because you can only type as many int as if you already know the number of inputs that need to be taken. Now if the number of inputs actually depend on the user itself, then you don't know it beforehand, and in this case there's no way you can write such a thing by simply using int and stuff. So that's where uh, arrays come into picture. So what can arrays do? So I can say that I need int, right? But I need an array of them. I need a collection of integers. So I can write it like int, and let's say the array's name is a, and this bracket over here would signify that I'm talking of array, and I have to give it a number. The number over here would be the number of elements you need. So let's say I need an array of 10 elements. So this would create an array of 10 elements for me. So enough of theory, I guess. Let's try to code it up. To code it, we'll open IDEON. The only reason I use IDEON and not my standard local setup is because I want to code in the same platform as you guys. And since everyone can at least open up ideon.com, it's not a big thing. So yeah, that's the only reason I'm using IDEON. So in the last lecture, we already talked about IOStream and namespace STT and this main function and the return statements. So yeah, let's get started with the array. So I'm taking an array int, array of int. I'm calling it a. It's of 10 elements, right? And let me print any element from it. So how do we print an element? So let's get back over here. So right now, what I'm saying is that create an array of 10 elements. So while explaining, this is the method I'll be explaining you. This is my array, right? So it has 10 elements. So it will start from 0. So this is the 0th element. This is the first element. This is the second, third, fourth, fifth, sixth, seventh, eighth, and ninth. But wait, shouldn't it have 10 elements? It already has 10 elements, right? Because we were starting from 0, we'll end at 9. And in total, it would have 10 elements. So this is my array. Now what if I want element at any proper location? So let's say I want the element at index 5. How can I get it? So in order to get the element at index 5, I just have to use this notation. I have to write the array's name, that is a in this case, and then I'll open my square brackets. I'll write the name or the number of the index I want to refer. So I'll write it like this. This would give me the value that's written over here. Let's say a value of 100 was written over here. Then I'll be able to get the 100 value by accessing it like this. How can I set a value? So let's say I want to set the element at the index 8 to be, let's say, 500. How would I do that? I can do it in the same fashion. So I'll say a of 8 is equal to 500. Now what would this do? This would set the value at the 8th location to be 500. So enough of a theory. Let's get back to the code. So I'll be accessing the element at 0th location. Cool, let's try to do it. Cool, over here if you can see, the standard output gives us a weird number. We didn't give this number to the system, but it's still giving us this number. Now why is it? We never talked about some number that's this big or has a value of 124,691,95,9456. Now these are actually called garbage values. Now if I try to print all the values in it, I can do that using a loop. I hope you still remember loops from the last lecture. So over here I can say that I want to print all the values that are there in this array. Let's try to print all the values. Let's see what's the output we get. Okay, so these are the values in the array. So we have a 21032 something like that, and then a small value, then a negative value, another value, another value. But all of these values are actually garbage because we never stored them in the array. So why is the system returning us this? Because we didn't tell the system what the actual values should be. So it assigned it garbage values, or it didn't assign it anything. So right now it's just having random values. Now what if we want to give some values? So initially we can initialize the array with some values like this. So we can say that, okay, the first element will start from the 0th element. So we can say the 0th element should have a element 0. The first element should be 1 2 3 4. Then should be this, then this, then this. Okay, so that's how we initialize. So you're saying the 0th is this, first, second, third, fourth, fifth, sixth, seventh, eighth, ninth. I actually gave a 10 okay, so yeah, that's a list of 10 elements. I told my system or the computer to create an array of 10 elements with these values. Now let's try to run it. Cool. Now our program runs and the values are already stored. So over here you can see that it's saying that the 0th element. Okay, let's do it even in a better fashion so that it's making more sense. I can see that at I, okay. Okay, so now I'm saying that the element at the ith location is this. Let's see, let's wait for the results. Yeah, so now it's saying that the element at the 0th location is 0, the element at the first location is 1 2 3 4, the element at the second location is 45, so on and so forth. The element at the 8th location is 312. Is it so? Yeah, the element at the 8th location is 312, the element at the 9th location is 35. So it's as easy as that. Now what we are able to do is that firstly we are initializing our array with some values, and then we are also able to change it. Now it told us that the element at the 8th location is 312, right? What if we want to change it to, let's say, something bigger? We want to make it this value. It's a big value, so I'm not even like trying to name it or trying to speak it out. But yeah, it's like 2,145,235. Yeah. So we want to make the 8th element equal to this number. Can we assign it like this? Let's try it up. It's running, success. Yeah. So the 8th element is now set to 2145235. Cool enough. So our logic is working, and now we understood that how we can make an array, how we can initialize it, and how we can store values in it. With that, let's move ahead. So over here we were talking about an int array, right? So my array only had integers in it. Can I have a character array? So character is also basic data type. Characters actually hold like alphabets and numbers. Basically anything you can type on your keyboard. It's an easy way to remember. Anything can be considered a character that you can type, right? So let's say I'm having a character array. Let's erase this up. Let it be actually. We'll make A as a character array. Now it can't have these values. So let's say it's of 5 digits. Let the first element be C. Let the second element be O. Let the third element be D. Then we can have E, right? And then we can have an exclamation mark. Cool enough. So let me comment this out, or let me just delete it. Cool. Over here I'll have to run the loop till 5 elements only, right, from 0 to 4. Let's try this, what it gives us. Okay, it's compiling, it's running now, and we have the answer over here. So the element at the 0th location is C, the element at the first location is O, then we have a D, then we have a E, then we have an exclamation mark. Superb. Now we were able to make a character array, right, and then print the elements. We can also perform the same operations as we did on a integer array. So we can say that the element at the second location needs to be a Z, right. Let's try to run it. Okay, it's running. Cool. So element at the second location has now has been now set to Z. Initially it was D. Cool. With that we were able to add values, or we were able to manipulate the values that were already present in an array. We were able to create the arrays also, and we learned how to create a char array and an integer array too. Now what are strings? We already discussed the char array, right? Now what's the need for strings? Good question. So what we can say is that if we have an array, we can't change its size. So we told that we need an array of 10 elements, right? And we provided it with 10 elements. Now in future, or in my code, I wanted to add one more element from like into it, or I wanted to delete one element from it. We can't do that in case of arrays. Arrays are fixed in size, and we can't perform such operations on it. So that means that we might need some special sort of a thing if we want to delete elements, or we want to add elements on the go. For that we have special things. So one of those special things is called strings. Strings is basically character array, but it's such a character array that you can add and you can delete elements from it on the go. After even you have initialized it, you can actually delete elements, or you can add elements on it. Let's see how we can write a string. So okay, over here, string A, I'm giving a random value, and I'll just print out string A. Let's see if it works. ID on it. Cool. So we made a string with some really gibberish values, and it printed that. We can actually change the value to whatever we want. Code a code daily. Cool. And then it will print that on the screen. The benefit, however, is that if this is a string, right? Initially we have a hard coded string over here. I can actually increase its size. So I can say that in this string I want to add another character and when I say push back, so it would be adding the character at the back, or it would be pushing the character at the back. So I want to push back, let's say Z, a capital Z. Now let's try to save it and run it. So it was the initial input we were getting, this one. Now it has actually pushed an element at the end. We can also pop an element. Now let's say I don't want to pop it like push an element, but I want to pop the last element. The last element over here is the exclamation mark. So I'll say a dot pop back. So pop the element that's present to its last. Let's try this. Cool. Over here the exclamation mark is now gone because we were able to pop the element or delete the element that was present to its last. We couldn't have done it if we were using a character array, but since we were using a string, we were able to do it directly. Also, in case of a character array, it would have required us to go through all the indices. So we would have said like go from the index 0 till index whatever, like 10 or something, and increment it, and then go through individual indices, then print them up, right? But over here we can directly print it. We can also use this. Both of them would work actually. So let me show you the thing in practice. So it's 1 2 3 4 5 6 7 8 9 10 11 12. Or you can actually say a dot size. So now what's a dot size? I'm actually coding it up, but yeah, a dot size basically gives you the size of the number of elements, or the size of the string a itself. So if I'm using it, my system would know that okay, I want to like traverse I from 0 till whatever the size of my string a is. I hope that makes sense. Let me give a slash n. Cool. Let's try it. Okay, you can see we have the exact same outputs. So in the above output, This is where the above output is coming from. So we are saying that print me a with an index I, and the indexes are going from 0 till n, where n is the size of the array. So we are able to print each individual index. This input or this output is exactly same as outputting the entire string, right? But it's more convenient. Now let's say you had to code this thing up, or you have a choice of coding this thing. So which is more convenient, which is more concise, or which would take you less time? So definitely this one, right? So hence we always prefer strings. Whenever there is a character array, there would be very rare chance that you would be preferring a character array over strings. For most of the time, for most of the things, you will prefer a string over a character array, and that's how we do it in the competitive programming too. So whenever you will be having a question that actually requires some computations on characters, so you'll most of the time be using strings itself. Cool. With that, now we know what a array is. We also know a special array that, or not a special array, but a type of array that's a character array. And we also know strings, right? And we also know that what are the difference between a character array and a string. So now what are vectors? So vectors are similar to, so if I say what's the difference between a character array and a string, we already know this difference, right? So now the difference in the character array and string is same as the difference in a array and a vector. Now what was the difference between a array and between a character array and a string? So the first difference was that it's resizable. It doesn't need to declare it with the size, so it doesn't require us to give the exact size at the input phase itself. We can pop the elements, we can push the elements, and do all sorts of computations, right? Same is the case over here. When we are using vectors, we don't need to provide it with the initial size. Even if we are not providing it with an initial size, that's completely fine. We can then push the elements, we can pop the elements, all of that things would work. So yeah, that's the entire difference between a vector and array. Although there are more differences, definitely, but this is the major difference, that a array is not resizable. So once you have given it, like you have hard coded it to be of 10 elements, it's gonna be of 10 elements. If you have said it is of 1,000 elements, it's gonna be that. But a vector is resizable. Cool. Now let's try to use vectors. Okay, so let's clear this code up. So how do we use a vector? We say vector, and then we provide the kind of vector it is. Like we said that array cannot have multiple data types, even a vector cannot have multiple data types. So I'm coding a vector of integers. So I'm saying vector, then I'll be using a less than sign, then int, or the data type it belongs to, and then a closing sign, or greater than or equal to sign, and then I'll give the name of this vector. Let's call it a, right? Let's try to assign it some values. So the way you assign values or elements to a vector at the beginning itself is that you can mention the number of elements you're going to use, and what shall be the value of each of the elements. So I want every element to have the value 100, right? I want 10 elements in total in my vector, and all of the elements should have a value 100. Now let me try to print this. Or over here it's 10, right? Cool. Would it work? So I've already given it a vector of type int. The name is a, it has 10 elements, every element has been set to 100, and then I'm printing the elements. Sounds reasonable, right? But would it work? Let's try it. It's compiling, and it gave an error. So it's saying vector was not declared in this scope. So if you have followed the previous video earlier, you would have seen this error when I was talking about cout and stuff. So now it's saying that in this scope vector does not exist, so it doesn't even know. So my program or the computer doesn't know what a vector is. Now the reason for that is the vectors were actually defined in another header file, and we haven't included that header file. So I'm gonna talk about a header file known as bits standard c++.h. This is a header file you cannot forget. So if you're going to do programming, if you're going to do CP, this is the header file that would be a lifesaver. because it includes all the header files. So if you remember this, then you don't need to remember any other header file. It actually contains everything you'll ever need. Let me delete the other header file. So now I only have one header file, and this header file contains a lot of STL. It contains like when I'm talking about STL, I'm talking about vectors. It also contains your standard input output and a lot many other things as well. So cool. With that, let's try to run it. Now I've already included this, so my system now knows what a vector is, right? Now let's try to run it. Cool, it's running. Yeah, perfect. So now it actually made a vector of 10 elements. The value of all those 10 elements was 100, and it printed 100 on the screen. Pretty cool, huh? So we were able to, over here we made a vector of 10 elements, and then we printed all those 10 elements. Now can I change the element or element and at any location? Yes, I can do that. So let's say I want to change the element at the third location to something like 700 or 7800. Can I do that? Let's try it out. So what it did is that it made the element at the third location. So this is the 0th location, the first location, the second location, at the third location. So the element at the third location has now been set to 7800, right? So yeah, the way we were able to manipulate arrays, the same way we'll be able to manipulate vectors as well. Although vectors are a bit more powerful than arrays because they allow us to add or append elements on the go. So over here, let's say I want to remove an element now, or let's say I want to add an element. Initially I'm having 10 elements. I want to add an element on top of on it. So I can say pushback. So what pushback does is that it pushes the element to the last. You can also use insert. So there's another thing called insert, and then you can add an element at any location you want. But for now we'll just be talking about pushback because this is the thing that's used the most actually. So let's push back an element. Let's push back some random value. Okay, so this is what I'm pushing back. Let's try to run it. So over here you can see that the value has been pushed, and this value is now present at the 10th index. Now if you count from the beginning, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So the 10th index or the 11th element. So because we are using a zero based indexing, the 10th element actually means the 11th. Oh, sorry, the 10th index actually means the 11th element. So that has been set to 141, 14125, 1235. Okay, cool. With that, we performed the basic operations on vectors. Cool. So we already discussed a few concepts, right? So we are already done with vectors. We also understood what strings are and what arrays are as a whole. Let's talk about stacks now. So what are stacks? So this is how I use a stack. Let's talk about it first. Cool. So we already talked about arrays. So in case of an array, I told you that you can use a method called insert, right? So insert method would insert the value at any location. So I could have said that this is my array, right? And I want you to insert value somewhere over here. So initially it is having 10, 10, 20, 30, 40, 50. I want you to insert a value 25 at the second location. So this is 1, 0, 0, 1, 2, 3, 4. This is the second location, but I want you to insert it over here. So what I want finally is it should become something of this sorts, right? Now it got shifted to the right, 30 got shifted to the right. Now it's at the location third, and at the second location I'm having 25. So this is something I can definitely do with vectors. Also, in case of a vector, I can select any value. So in case of a vector, I can say that okay, I need the element at location second, right? And that's a valid thing to do in case of vectors. However, when I'm talking of stacks, so if you want to study like understand this, you can say that these are the things that you can do with vectors, right? These are all the things that you can do with vectors. Now this is stack. So what that means is that there are a few things that you can do with stacks, and all of these things can actually be done with vectors. Why I'm saying this is because stack actually helps us to perform only limited operations. So the operations you can perform with stack is that you can push an element to the last, like we were doing with we were doing with the arrays. So you can say push back, Okay, push back, or you can say pop. So what a pop would do is that it would pop the last element. So if this is your stack, it's having 3 4 5 6, then it will pop the element 6, right? And in this you can also say top. So what top would do is, so when we talk of stacks in particular, we don't write it in a linear form. So we try to write it somewhat like this, right? So there is my 3 4 5 6. So this technically is the top element right now, right? This is element at the top. So when I'll be calling stack dot top, it would return me the greatest element, or not the greatest element, but the element at the top, right? So it would return me 6. What would happen when I pop it? When I pop it, it would delete it, right? Now what would happen when I push an element on my stack? So it would push it. So let's say my stack was right now 3 4 5, and I want to push a 0 on it. So when I push it, it would get appended on the top itself. Cool, that's what a stack is. Let's try to code it up. Let's try to understand what a stack is. So that's how you define a stack. Like we was defining a vector, we were saying vector int, we will say stack int over here. We'll call it st maybe, and then we can push values on top of it. Like we can push 1, and we can say st dot push 2 or push 3. Then we can push some other values 4. Now let's try to get the values out of it. Now I'll be using a while loop over here. I'll say while it has some size or it's not empty. So this is the not symbol. This symbol right over here is the not symbol. So it's basically saying while it's not empty, right? So the way I'm going to write it is while st dot not st dot empty. While it's not empty, I want to print the element at the top. So let me print the element at the top. I hope that's making sense. Cool, let's try to run it. Let's save it, let's run it. Okay, it gave a runtime error. Okay, so why I'm giving a runtime error over here? Any guesses? So that's happening because I'm saying while it's empty, while it's not empty, return me the top element. But what's happening is that in the loop, it's never getting empty at all. So it will keep returning me 4. It will keep returning me 4 because 4 was the element at the top. 4 was the last element that we pushed. So it was the element at the top. Now in each of this iteration, the element at the top is always 4 and it's never empty. So it will keep printing 4 till the time the system crashes or the application crashes. So what can we do? In each iteration, I'll try to pop the biggest element from it, right? So now let's try this. Cool. So now we got 4 3 1. So what this means is that we had a stack wherein the bottommost element was 1, then we had the 3, then we had the 4. So firstly, when we checked what's the element at the top, it gave us a 4, right? Then we said pop it. So when we said pop it, it popped it up and gave us a value 3. Then we said okay, that's good enough. Now pop it. So now it popped the value 3, and the element we were left was with 1. So it then printed 1, and then it popped 1 itself. Now it got over here, then it checked if I'm empty or not. Now it said you are empty, so you have to like come out of this loop, and we came out over here. Now in the previous lecture, I had already asked you to study what while loops are. If you haven't studied that yet already, you should definitely have asked me on the Discord server. Cool. If you did that, it's good enough. If you haven't studied while loop, pause the video right over here. Go and study while loops first, because while loops are kind of important. I could have done the same thing with the help of a for loop, but it's more intuitive to use a while loop in such cases. So that's why I went with the while loop, and you should also study while loop. Cool. Let's move ahead to what are queues. So what's a queue? In case of a stack, what I did is that I kept pushing the value on the top, right? And when I was removing the value, I was removing the values from the top. Now in case of a queue, we'll insert the values from a certain endpoint. So let's say if we are talking about top and bottom structure, so I'll keep adding the values on the top, but when I'm removing it, I'll remove them from the bottom itself, right? So let's try to understand that. So I already told you that what stacks are, and there's a reason we represented it like a bottom up structure. Now let's talk what queues are. So this is a queue, right? So you will be having elements. So let's say so initially it's empty, so it's having nothing, so it's a emptiness. I said that okay, I want a queue with the element 10. Perfect. Now I said, okay, add one more element, that is 6. Okay, I added that as well. Now I said, add one more element, that is 3. I added that as well. Now I said, get me the front element of the queue. So now I'll be getting the front element of the queue, that is 10. That I can do. Now I say that pop this element. Cool, I can do that as well. So I popped it. Now I said add 8. So 8 would be added over here. Now I said, what's the front element? The front element is 6. Okay, pop it up. I'll pop it. Now how many elements I'm left with? 2. What's the front element? 3. Pop it. I'll pop it. What's the front element? It's 8. Do I want to pop it? Maybe, but I don't want to. So add another element. Add another element. That's called 9. What's the front element? The front element is 8. Do I want to pop it? Yep, pop it. I popped it. What's the front element now? The front element is 9. Do I want to pop it? Yep, pop it. So I'm left with nothing now. So I'm left with the empty queue. Cool enough. So what we understood is that a stack is a first in, last out. Why do we call it this? Because if I'm adding an element on my stack, and then I'll keep on adding, like I added 1, then I added 2, then I added 3, then I added 4. Now when I pop them back, right? So I'll be popping this first, then this, then this, then this. Now 1 was the element that was pushed in pushed in first, right? And it's coming out at the last. That's why it's called first in, last out. So whatever elements gets in first comes out last, and the element that comes in last gets out first. So 4 was the last element where it is that we added, last element to be added, but it was the first element that got popped out. Cool. So I guess FILO or first in, last out now kind of makes sense to you. What about queues? Queues are first in, first out. Why so? So in case of a queue, whatever element was coming in the first was getting out first. So 10 came in first. Now when we tried to pop it, we popped 10 first, right? Then came 6. So we popped 6 then. So in the order that the element actually started coming in the queue, they'll be popped out in the same order itself. So that's why it's called a first in, first out, and a queue and a stack is called first in, last out. How do we define a queue? We define a queue in the similar manner. So we call it QUE. Then we have to name the queue, let's say Q. Then we can push the elements in the same manner. Also over here, I can use the same structure, but I'll not be talking of the top element. Now we are talking of linear elements arranged in a linear order. So the term I'm gonna use over here is called front. So I'm gonna check the element at the front, and then I'm gonna pop it, right? Let's try to run this. Okay, I'm using a ST over here. Let me use a Q. Cool. It's compiling, it's running. Yeah, 134. What was the value I was getting for the stack? I was getting a 431 because it was push popping out the value, or was telling me the value that was available at the top itself, right? Or the value that was pushed in at the last. But in case of Q, we'll be getting the value that we are pushing in first. So first we pushed 1, right? So when we'll be taking out the values from a queue, we'll get 1 first, then we'll get a 3, then we'll get a 4. Now way to visualize stack is actually when people are standing in a row or in a queue, right? So now if let's say it's a movie counter and there are 5 people who are standing. So what would happen is that the person who comes first, or who is standing at the first location, would be served first, and then when he's done, the second person would be served, so on and so forth. In order to understand stack, you can say that chairs are piled one on the other, right? So if you keep chairs one on top of other, or if you keep anything one on top of the other, right, when you want an object out of it, you'll be picking out the object that's there on the top, right? That's the only way you're gonna get that object. Cool. This was a basic definition. I don't want to stretch this concept. I want to cover everything. I want to give you a gist of everything in STL. So that's it. I'll be only talking this much about it. Let's talk about unordered maps now. So what are unordered maps? So for unordered maps, there's a bit of mathematics required, but I'm not going over that. Just wanted to give you a brief overview and not the detailed overview. Definitely we'll be talking of the detailed overview later, probably when we'll be talking of hashing and stuff. But for this video, let's just keep it to the point where you know what hash maps are or what unordered maps are. So unordered map is basically a key value pair. So you'll have a key, then you have its value, right? For example, you can say that what's your name? So name is the key. The value is your name. So my name is Pranav, so I'll write Pranav over here, right? What do you do? So do. So anything basically. So the name here it was name, or here it was a profession. So it could be profession. The key could be the profession. And over here you can say engineer, right? So basically key value pairs are called hash maps. Now how and where can they be used? They can be used at a lot of locations. Now let's say I want to keep a track of frequencies of the elements. So I have an array that's 1 2 3 1 4 1, right? Now I want to keep a track of frequencies. By frequency I mean which element appears how many number of times. So over here 1 is appearing 3 times, right? 2 is appearing 1, 2 is appearing actually 1 time, 3 is appearing 1 time, 4 is also appearing 1 time. So I want to keep a count of it. So I can use a array or a hash maps. I can use a hash map to keep a count of the frequencies. So I can say that 1 is appearing 3 times, that 2 is appearing 1 time, 3 is appearing 1 time, 4 is also appearing 1 time, and that would be perfectly valid. Now let's see how can we code it up. But did you realize one thing? We were not actually using, or we were not changing the header file even when we were using the vectors or stacks, or now even we are using unordered maps. That's because bit standard C++.h is such a header file that it contains almost everything you'll require. So even with this one header file, everything would already be present for your program to work on. Cool. So the way you say unordered map is unordered underscore map, and then you provided two values. So what are these two values? This is the data type of the key. This is the data type of the value. Let's call it MP. And I can say that MP. MP is basically the name. So you can write anything. You can give it, okay, not this, but you can say this. This is the name. But I'm just trying to keep it short, so I'll call it MP, right? Then I can assign key value pairs. So I can say MP10 is for 123, MP532 is something of this sorts, or this sorts, right? Now I'll try to access a value that I have not actually provided. So now in order to access a value that is present in the maps, I use the same notations as I use in case of arrays. However, inside this square brackets, I need to provide the key, right? So over here, let's provide a key that that I've already assigned. So I would assigned the key 10, a value 123. So let's see what's stored at the key 10. Let's try to run it. It's compiling. It's running. Yeah, 123, because we wrote 123 at the key 10. Now let's try to access a key that we have not actually coded up or provided. So let's try for the key 11. So over here we have only provided it with two keys, 10 and 532, not with 11. So what would it return? Yeah, it returns 0. But why is that case? So what happens in case of maps is that if you try to access something you have not already provided, then it returns a default value. It returns a default value. But why 0? So it returned us a 0 because the default value for an integer is 0, right? So as soon as it detected that I don't have a value corresponding to 11, so it returned us a default value for integers, that is 0. This would happen for any element if it's not assigned already. So let's say MP 100, even 100 is assigned. Let's check for that as well. So yeah, 0 and 0. Cool. So with that, array is also completed. Now the use cases of, not arrays but unordered maps is also completed. Now the use cases of hash maps on or unordered maps are actually immense. They are used in a lot of algorithms or in a lot of problems. But in order to solve problems based on hash maps, you need to understand more concepts for that. That's the only reason I won't be discussing those problems in this particular video. We'll definitely be coming to the problems too. We'll try to solve a lot of problems, but definitely not in this video. I'm just trying to give you an overview of STL in this particular video. So yeah, with that, unordered map is also done. Now what are sets? Cool, let's come back to sets now. Cool. So sets are basically representation or arrangement of elements. Also, even sets can only contain a single data type, so it can contain int, it can contain a character or anything, but not more than one data types, right? So sets are also collection of a single data type, and the unique property of a set is that the element would be ordered. So over here we can say that the element at the first, when we'll take the element at the beginning. Also, we can't refer to a set as we referred to a vector. So in case of a vector, we were able to say that okay, give me the element at the 8th location, right? Or give me the element at the 7th location. We can't do that in case of a set. In case of a set, because set are internally implemented in a completely different manner. Now it is implemented as a tree, and that's way too complicated and way too out of the scope of this video. If you want, you can Google it up, but yeah, it's complicated, and if you are a beginner, don't try to do that. But like, even if we have a set, right? So I made a set and I assigned it values, so I'll be inserting values into it. So let's say I'll insert maybe 10, then I inserted 20, right? Then I inserted maybe -5. So I'm talking of an integer set, and I inserted these values into it. Now if I can't access it via this format, wherein I can give it the index I'm trying to access, how can I access it? So the only way to access a set is to get the smallest value present in that set or the largest value. So I can say that I want the smallest value. So smallest value is present at the beginning. So I can say return me the smallest value. Cool. So I'll say set dot begin. But this would return me a pointer. Not a pointer but an iterator. So what is an iterator now? So cool. Let's say this is the values that the set is holding. So it's holding 10, 20, -5. So I said give me the beginning value of the set. So it will give me a iterator. So iterator is something like, it's like a thing that's pointing to something. So this is iterator. It say that okay, so my beginning actually is pointing to this, but I want the value. I don't want whatever you're pointing to. I actually want the value of it. So what I can do, I can use a div reference. So by using a star, I can say whatever I'm being pointed to. So it is basically what I'm pointing to, right? So I can say whatever I'm pointing to, give me the value of that. Let's try to see it in practice. So that probably would make more sense. So I can say I have a set int st, in that I'll insert the value. So I'll say insert 10. I'll use the exact values as I gave you in the explanation. Then I'll be inserting -5, right? Now I'll say give me the beginning, but now it actually is saying that I'm a pointer, I'm not a value. So let's try to run it, what it gives us. Okay, it gives us a error or a compilation error. It says that I cannot print it. So you are trying to print a pointer itself or iterator. I can't print a iterator. In that case, what can I do? So I can dereference it like I explained. So I can say give me the value that's present at this location. Cool. So now it's giving me a value -5, right? It's saying that the location or at the value at the smallest location is -5. That's pretty cool, huh? What if we want to delete it? Can we delete it? Yes, we can delete it. We can simply say delete the value that was present to your beginning. So I'll ask my set to delete the value or erase the value that was present at the very beginning. So would this work? Yeah, it's working, it's running, because yeah, now we get a -5 value. But how do I confirm that the value was deleted? Let's try to print the value at the beginning again. So at this position I print the value at the very beginning. Print beginning. Now I asked in this statement to delete the value, and now I'm asking to print the value again. Now what should be the answer in this particular case? I've already deleted the value that was at my beginning, the value -5. So what shall be the answer? Let's try to run it up. Now the initial value at the beginning was -5, that was the smallest element, but then it deleted -5. It deleted the element at its beginning, that was -5. Now the element it's left with is 10, right? The smallest element, the elements that it's left with are 2, 10 and 20. The smallest amongst them is 10, so it will give me a 10. It's as simple as that. Now one thing that you should note with set is that it contains only unique elements. So if you are having multiple elements with the same value, so let's say I insert 10 multiple number of times, and then I want to check the size of it, right? So I'll say st.size, right? Let's check the size. Oh, it's returning 3, but I actually added 1 2 3 4 5 elements, right? So the only reason it's returning 3 is because it has only stored 3 elements. Since I was storing 10 multiple number of times, it only takes, or it only saves it once. So in the set we are only having a single 10. Now if you want to get rid of this, you can actually use something else, so something called multisets. So if you want to store multiple values, you can use a multiset. Now let's see what a multiset does. So a multiset actually stores even the duplicate values. Now since it's storing a duplicate value, we are getting answer 5, because now 3 instances of 10 is stored, 1 instance of 20 and 1 instance of -5 is stored. Cool. With that we cover multisets as well. If you are not liking the pace of this video, I would really urge you to see a concept. Maybe I'm covering it in 5 or 10 minutes, then pause the video, try to code something on your own, try to play around with it. So now we'll be discussing of unordered sets. So what are unordered sets? Unordered sets are similar to sets. The only difference is that they don't maintain a order. So what do I mean by that? So I already explained that a set actually contains the value in a ascending manner. So the value present at the beginning was the smallest value in the entire set, right? However, in case of an unordered set, it won't be that case. So in case of an unordered set, the value at the beginning is not necessarily the smallest value. Well, I won't be coding unordered sets over here, but if you want to see the code, it's something like this. So unordered set int, then you can insert the value similar to a set, then you can reference it like I referenced it in a set. So let's try it out. It's compiling, compilation error, st was not defined. Okay, so s was that. Cool, we are getting a 10 because we only stored one value. Now let me store some other value. Let's say I store maybe 100. Let's see what's the answer. Okay, even now we are getting 10. Let me store some other value. Let's say 1. Let's check this. Okay, so over here you can see that we have a value 1 present, which is the smallest value. However, when we are looking for the starting value present in the set, we are still getting a 10. However, the smallest value is 1. So this means that the values in an unordered set are not actually ordered. That actually is pretty clear from the name itself. I still just wanted to show an example. Also, in case of sets or maps or unordered sets, like whatever we are using, one important thing is that you can also always use a method called as find, right? So there's a method called as find. So you can say s.find, and you're trying to find a value 100. So I hope if statement is clear to everyone, I can say that if I'm not able to find it, my system would return me an end pointer, or it would return me a iterator that is pointing to the end location, right? Okay. Okay, so over here we are saying that if the element is not found, or if the element is not being pointed to the last, that means if it's not being pointed to the not being pointed to the end, that means the element was found and we have a iterator to it. In that case we can say found, else we'll say not found. If I try to run it, let me delete some more things. Yeah, if I try to run it, now I'll get a found. What if we say something that was not present in over here? Let's say we typed something else. Let's say 200 or 400. Let's try to run this. Cool. So now it will give me not found because 400 was not in the set and unordered set, and as soon as we tried to find it, it returned so for 400 it returned us a pointer that was pointing to the end. S dot end is actually something invalid, so it's returning me a pointer to a location that actually is invalid. It's saying that I don't have this value. If that is the case, if it's returning me a pointer to the end, that means I don't have a valid value with me. That means the value is not present in me. In that case I can't do anything with it. I'll just print not found. But if it's not returning me that, so it's not equal to, if it's not equal to s dot end, that means I was able to find a value, so I can return found. Cool, that was about unordered sets. But believe me, if you are comfortable with unordered maps, right, you'll never actually use unordered sets. I myself quite rarely use it. You can say most of the times I actually use unordered maps, unordered map whenever I need to store the values and find it in such a fashion. So this is quite rarely used, but it's still good to know. That's the only reason I explained it over here. Let's come to priority queues. What are priority queues now? Priority queue. Okay, so priority queue is a data structure or is a way of storing the data such that the value at the top is always the biggest. Cool. So what's the benefit of it? We could have actually stored it in a vector and make like sorted it up and stuff, but what's the benefit of it? So the benefit is that if you want to insert any value, right, in a queue, we can do it in order of log n complexity. So this is of order of log n complexity. If you don't understand complexities right now, don't worry, I'm gonna make a video on that as well. So cool, whenever we are inserting a value, it's done in log n complexity. Whenever we will be deleting a value, so can we delete any element from a queue? No, we can't. The only element which we can delete from a queue is the biggest element. So by default this is called a max heap as well, right? So max heap means that the element at the top would be the maximum element, right? And that's the only element we can delete. So in order to delete an element, we use the pop statement. Let's see it in practice. So let me insert, or it's not called insert but push. Yeah, so let me insert, let me push two elements to this queue or this priority queue. Cool, let me now print the biggest element. So it's given by top. Let's try this up. It's running. Okay, it's saying that the biggest element or the element that's being pointed at the top is 1200. Let me add some other elements so as to make it more clear. Okay, I added an element 300. Now over here I popped it, and then let's take what's the element at the top. Cool, let's try this out. This probably would clear some concepts. So initially we had three elements in the queue: 100, 1200, 300. So the initially we wanted to print whatever the element is at the top, or whatever the biggest element is. So we asked it for the element at the top. It returned us 1200, right? Then we popped the element. So when we pop element, the element at top is popped or is removed. Let's say removed. Now the element now which is at top would be 300 itself, because we are left with after we deleted this, we were left with two elements, 300 and 100. Out of this, 300 is bigger, right? Hence the element at the top would be 300. When we printed that out, we got a 300. Cool, that's about priority queues. They are actually used a lot, but the way to use them would come with practice. Like even if you see a question, so if you want to make out that whether you are going to use priority queue over here, that actually requires some practice at least. So we'll definitely be covering it soon, but not in this video. This video is already lengthy, I guess. Yeah, this video is already lengthy. I don't want to push it further. Now we are done with all of these things. I hope you have a basic idea, right? This video was not meant to give you an in-depth knowledge of STL, but just a basic idea. So when we'll be using it for questions, you are able to understand it. Whenever I say we are going to use an unordered map, you are able to understand what an unordered map is. Or if I'm saying I'm going to use a priority queue over here, you have some sort of an idea what a priority queue is. You're not completely lost. That was the entire motive of this video. I hope that motive is actually fulfilled, right? Now what are iterators? We already talked about iterators, right? So we already talked about that I'm having something that's pointing to the starting of a set, something of that sort, right? So all of those things are called iterators. Now there's a way to move the iterators from one position to the other. So what we can do is that, okay, let's give you a small example for iterators. So this was a set we were having, and then I'm adding some values into it, right? Let me add some values. Okay, so these are the values I added. Then I'll write auto IT. Okay, so what is auto firstly? Yeah, so auto basically is like we discussed data types. We said that everything needs to have a data type. So over here, the iterator has a data type of, I think it's written something like this, right? It is an iterator, so we call it this, right? Let's try it. If I missed, let's just see if I messed something up of, or it's perfectly fine. Let's try that. Cool. Yeah, this is how you write the this is the data type of a iterator, or this is how you represent a iterator, right? But this is too complicated. You don't want to write it like this. So what you can use is auto. So auto is something that tells the computer that assign it the correct data type. So I'm assigning the value s dot begin to it. So system would know, okay, if you are assigning a iterator to this particular variable, then the type of this particular variable should also be the iterator, right? So it will assign the automatically this value to it, but you don't need to do it on your own. You can simply say auto it is equal to s dot begin. That will work just fine. Now what I'm doing over here is that I'm taking an iterator to the beginning of the set. The beginning of the set would contain the smallest element, so it's the beginning would contain 40 right now. Now what if I want to go to the second element? So I already told you that set does not support uh, accessing random elements, so we cannot access the element at the 0th location, then at the first location, right? So there's no way I can say that print it2. There's no way of doing that, right? Instead what we can do is that we can increment it. So when I increment it, it would go from the first element to the second element, or from the beginning to the next element. So let's try this out and print the value now. Let's try this. Okay, over here you can say that initially I was having a value 40, that is the value at the starting index. Then I incremented my iterator. So now I'm saying that the iterator would point to the next element. So what would be the next element? The next element would be the element that's just greater than 40. So in this list I'm having 100, 200, 150 and 40. So I'll be having element 100 that would be next to 40. So it printed printed 100 over here. So that's it about iterators. You can also use some other iterators like okay, so you could have actually used rbegin. So instead of a begin, we can say rbegin. So rbegin basically means reverse begin. So it gives us the pointer to the end. So basically the pointer that's exactly to the end of the set, and it will print the biggest value. Because I'm pointing to the end, it should give me the biggest value that is present, right? So yeah, we get a value that's present at the end. So the biggest value is 200, so it's giving me a 200. So that's about iterators. There are definitely a lot more things you can do with iterators, but this video is just to give you a brief overview of it. So I think that part is already done. What about functions now? So there are a lot of functions, but I won't be able to discuss all of them. I'll share the links to some good websites that talk about this function in detail. So this is a website called CPP reference. You can follow that. I'll provide the links to that in the description. So let's say I have a vector v, right, and it has some values. Let's say 1 2 24 512 553 135, right. Now let me print these values. So I can print these values using a auto for loop. So if you don't have any idea about auto for loop, do some research. If you don't understand, uh, the Discord server is always there. The reason I ask you to do some research is because when you are researching something on your own, you tend to tumble upon some other stuff as well, and your knowledge increases. That's the entire reason I ask you to do some research on your own. Not like I am being lazy or something, but it's always better for you to do research. Cool. Now this is the way I can actually access all the elements that belong to C. Let's try it out. It's running. Okay, so I got all the elements that are present in my vector v, right. Cool. So I'm having 1 2 542 512 53 135. What if I want to sort it? Sort this. How can I do that? So the way I can do that is I can say sort. I can give the initial pointer and the pointer at the end, right. So this function, this small piece of code, would do the sorting work for me. It's already defined in bits library or the bits header file, so you don't need to worry about the implementation part. It's pretty quick and it's pretty fast, it's pretty efficient, and it's always correct, so you don't worry about that. So yeah, as soon as you run it, it would have already sorted the values. So when I'll be printing the values, it would be in a sorted manner. So yeah, initially the values were not sorted. For example, 542 was coming over here when we have a 53 ahead of it, so definitely not sorted, right. Now I utilized sort function to sort all the values, and now they are sorted. So they are sorted like 1 2 53. Now what if I wanted to sort it in a reverse fashion? So I can give it the reverse iterators, right. I'll give the r begin and the r end iterators of the vectors to the sort function, and now it will be able to sort it in the reverse order. So now this is sorted in the reverse order. So it has a 542, then a 512, then 135, then a 53, then a 2, then a 1. Pretty cool, huh? So with this, I think even the functions are done. Is sort the only function available? No, you have a lot of functions. So we have a function called partial sum, right. Then we have something called accumulate, but these would come as you grow and practice, and as we solve questions, I would be discussing about these functions in detail. But let's discuss about accumulate at least. Accumulate is a easy thing. So accumulate performs the operation on all the elements. By default, accumulate would be performing a sum operation. So if I give it the beginning at the ending iterators of this vector, right, and I give it with the initial sum of 0, right. Let's try to print it. Also let's try to reduce the size because it's actually too big. Cool. So let's try it up. Okay, so over here it says 35. So what's 35? 35 is actually the sum of it. 1 plus 2 is 3, 3 plus 32 is 35. I'm calculating the sum by using a simple formula or a simple function. The name of the function is accumulate. I'm providing the beginning iterator and the ending iterator to this vector, and I'm providing with the initial value. What if I change the initial value to 100? Let's try that. Cool. Over here now the sum happens to be 135. Why is that the case? Because when it starts computing, it takes a initial value this. So if I say that you start with 100 itself, it will say 100 plus 1 is 101, then 100 plus 101 plus 2 is 103, and then plus 32 is 135. That is what it's going to print over here. So make sure you always provide it with 0 if your intention is to calculate sum. You can also perform like you can give it your own like definition, or you can give it your own functions, but that's a bit complex topic. We'll study it some in some other video. For this, I guess we covered a lot of things. By this time, I don't expect you to be masters in STL, but at least you know the basics. At least you whenever you come up with some code, or whenever you are seeing code of some other person, you'll be able to understand that why is this person using a STL over here, or why is this person using a set or an odd map over here, and is there an alternative to it, what it actually is performing. All of those things would have already been clear, I guess. But still, if you have any doubts, please let me know in the comment section below, or you can ping me on Discord itself. It would be better if you ping your doubts on the Discord server, because that way other people can also learn from your learnings, right? Cool guys, that's it for the video. Thanks a lot